Our motivation for this project was to help children with disabilities interact and engage with their peers. This is very important as researchers from the American Academy of Pediatrics found that play fosters creativity, confidence, and relationships with other children, which is critical to a child's development and level of happiness. Creating the modified pie in the face game would allow these children to be included in an activity that they weren't able to participate in before and benefit from interacting with their classmates. Currently, there is a modified game being sold online, but it is expensive and impractical for large groups of children to play with. Our design would provide a cheap alternative that would benefit children with muscular disabilities. Our assignment was to create an adapted pie in the face game for Sue Schmidt of the Madison School District. The game was to be adapted so students with muscular disabilities are able to play, and the game isn't about throwing pie in someone's face, instead about throwing a ball into a net. The adapted game allows children with limited strength to simply press a button, which then swings up an arm and throws a ball. Children who have these disabilities often have trouble engaging with their peers through activities, and our job is to create a game that can be played by everybody.
Our group used client meetings to be able to understand the problem behind the game Pie in the Face and the significance of it. During our meetings with our client Sue, we asked different questions in order to understand what was needed and what she wanted to see in the final product.
Our client gave us a few very specific design specifications. The first being she wanted it to be smaller so it could be used inside of the preschool and fit on the tray of a wheelchair. She also wanted it to be a gentle throw and children-friendly, as this would be used inside of the classroom. She also gave us a few design requirements. She wanted it to be portable, easily to move around the classroom, and operated by a jelly bean switch or a proximity switch. With these requirements in mind, we met and we began brainstorming. Our project was very specific in the fact that we had to adapt the pie in the face game, which didn't give us much variety of what we could come up with. We all wrote down all of our ideas, and we were able to manage to bring it down to our top 3 ideas.
There were 3 designs we presented to our client. Design 1 had an attachment on one side of the original game to hold the electronics. Design 2 had an extruded base attached to the bottom of the original game. And the third design would be 3D printed from scratch with more electronic components to it. This was the design matrix we used in order to decide which design to use. The criteria included safety, fun, effectiveness, durability, creation difficulty, and cost. And we made a decision to go with design 2 based on our meeting with our client and the design matrix.
Going off our second preliminary design, the Extruded Base design, we plan to fabricate the new base of the game by 3D printing it in separate parts, then screwing them together and attaching it to the original game with a nut and bolt. We plan to 3D print the smaller parts we needed, like the arm that would launch small objects, and the attachment between the motor in the game and the gear that would attach to either side to provide a moving visual component. The new targets or goals would replace the original face cutout and would be made with a vinyl cutter using similar material as the original. We would assemble the circuit after testing it using a breadboard by soldering all the wires and components to a perf board. And then finally, we would attach all components to the game and fix them inside our new fabricated base.
We had 3 different options when deciding which motor should be used to turn the crank of the adapted game: DC motor, servo motor, or stepper motor. To test all 3 motors, our team set up 3 Arduinos with 3 breadboards to test the circuitry for each motor type. After the tests were complete, the team chose to use a stepper motor due to its ability to take small steps and turn the precise crank distance. The Arduino-controlled circuit is comprised of a jelly bean switch, an Arduino Uno, an H-bridge, and a stepper motor. If the team had time to test the circuit, we would have first built and debugged the circuit on a breadboard, and then have transferred the circuitry on the breadboard to a much smaller perf board. These components would then be placed inside the added exterior base of the adapted game, and the motor would be attached to the crank of the game.
Another category that we needed to test was the launching capability. One of our clients' needs was for the ball to be launched around 2 to 3 feet. We were going to test our initial prototype around 10 times and average the distance over the 10 trials. If the average was between 2 and 3 feet, then we would stick with what we had. However, if it was too far or too short, we would change the weight and length of the arm attachment. If the ball was being thrown too far, we could add weight by changing the material that the arm was 3D printed with, or we could shorten the arm length, and vice versa if the ball was being thrown too short.
And after all the brainstorming, designing, testing, and improving, this is our final project. It shows all the specifically designed parts all in one assembly. We hope that our modification of the game provides a fun, exciting, safe experience for all children. All of us from the Bucky's Mini Ball Launcher team would like to thank Sue Schmidt, Dr. Soros, Thor Larson, Rebecca Allock, and everyone who has helped us finish this project. Thank you.